Hey everyone, welcome to the new video. Today's problem of the day is New Year resolution. So let's see the problem statement. In this problem, a programmer makes a resolution to solve problem of the day every day. And he was eager to earn the coins for GFG merchandise. But the programmer faces some new rules. The first rule was he can accumulate a certain number of coins on a specific day, and the sum of all the coins given must be less than or equals to 2024. The next rule is the coins earned by him must be divisible by 2024, or it must be precisely equal to 2024. After that, in the program, it is given that the programmer's new resolution fades over the time, and realistically, he only commit for n number of days. So we are given with the value of n and the number of coins associated with each problem of the day in an array. Now our task is to find that can Geek strategically solve some problems to become eligible for redeeming the merchandise of Geek for Geeks. This is our task. We are given with two examples. Let us discuss it quickly. This is our first example. So the programmer has to program for certain number of dates and collect some geek coins so that he can meet the given conditions in a problem. So let's see whether the programmer can be eligible for merchandise based on this example. So according to the problem statement, we have to check whether the geek is eligible for merchandise or not. And the conditions are the sum is exactly divisible by 20, or the sum is exactly divisible by 24, and lastly the sum must be precisely equals to 2024. These are the given conditions. Now let's check whether he can code for certain number of days and collect certain number of coins which meet one of these conditions. So if the programmer codes for the first day, he will get 5 points, and the minimum points he has to get is 20 to satisfy the first condition and 24 to get the second condition. So let's keep on iterating through the given array and see whether he can meet this condition or not. So first day he gets 5, and if he has to collect 20 coins, then he can work on the fourth day as well. So all total he got 15, and in the last day if he codes he will get 5 point more. So this is equals to 20, and thus the programmer is eligible for merchandise. Now let's take the second example as well. Here also we have to check whether the programmer can meet these conditions or not. If we sum them up, all the elements, we will get, so the sum itself is less than 20 and 24. So the first two condition can never be achieved. So the sum itself, as we can see, is less than 20 and 24. So the first two conditions can never be achieved. And also the last condition, where sum is equals to 2024, is not satisfying. Thus we can say he is not eligible for Geek for Geeks merchandise. Now let's discuss what can be our approach to solve this problem. At first, we will store the sum of all the coins in a variable which a programmer can gain if he codes for a number of days. So in the second case, we got 15 as our sum. Now we will create an matrix. So we have to deal with all the possible subarrays of the given array and check whether the total of those subarray meets these three conditions or not, or even the whole array meets this condition or not. So for that we will be using dynamic programming approach to solve this given problem. We will create a matrix whose number of rows will be equal to n plus 1. So let us create the number of rows in our matrix. That will be 5 plus 1 is 6. So we have created the rows, and the columns will be sum plus 1, that is 16 number of columns. So we have created our matrix. Now our rows will indicate the days, and our columns will indicate the maximum number of coins he can collect in those days. So now we will enter value in our boolean type matrix. In the first case, when I and j is 0, so 0 comma 0, this indicates on the 0th day, can we achieve 0 coins? This is true, right? We can achieve 0 coins in 0. Without coding, we can achieve 0 coins. So we will simply add true. Now let's increase our row, that is first row and 0th column. This is indicating while coding for 1 day, can the programmer achieve 0 number of coins? This is also true. This is possible. 0 can be achieved without coding also. So this column will always be true because 0 number of coins can achieved at any day. And this is how we will update all the indexes of our matrix. Now we will update our I will be increased by 1. So in our 1 comma 1 index, we will check if 1 coin can be earned by coding for 1 day. So if we consider this example, we can see if the programmer works for first day, he can gain one number of coin. So this is true. Then we will update our value of first row, first column by true. Now j will be updated. Let's see for the index of 1 comma 2. That means a programmer working for a day and gaining 2 coins. Is it possible? By coding on his first day, he can achieve maximum 1 coin. So 2 is never possible. So in the first row, second column, we will update false. And in this way, every column will be updated by false till the sum. Because we can't achieve 15 in first day. Because maximum we can achieve only 1 coin if we code on our first day. Now our I will increase again. I will be 2 and J will start iterating from 1 again. This is indicating that while working or coding for 2 days, can the geek achieve one number of coin? So let's see the example. Working in these 2 days, can he gain 1 coin? Yes, in the first day only he is gaining 1 coin. So we will update the index with true. That is 2 comma 1, second row, first column. We have updated the index by true. Then our j will increase, j will come here. So in 2 comma 2 index, we will check that while working for 2 days, can the geek achieve 2 coins? This is also possible. While coding for the second day only, he will get 2 coins. So we will update this index by true. Now j will again increase. So in 2 comma 3, this is indicating that working for 2 days, can geek achieve 3 coins? So if he code for 2 days consecutively, we will get 2 plus 1, that is 3 number of coins. So we will update the value of this with true again. After this, when j becomes 4, we have to check if the geek codes for 2 days, whether he can get 4 coins or not. This is not possible in any way because in the first day he is getting 1 coin and in the second day he is getting 2. So all total in 2 days he can get 3, maximum 3 coins. So this is false, and from now every indexes will contain false value. You can check this because our sum is increasing from this index and the maximum coins we can earn is 3. So rest of the indexes will be false. Now after this iteration, I will be increased, I will be updated by 3 and j will start from 1 again. So as I have said, I is indicating the number of days he is coding and j is the maximum coin he can earn. So this index is indicating that while coding for 3 days, means these 3 days, can the geek achieve 1 coin? This is true. In the first day only he is getting 1 coin. So we will update the value. Now j will be increased. So 3 comma 2. Can the geek achieve 2 coins while working for 3 days? This is also true. In the second day he is getting. So we will update the value by 2. Like this we will update all the values for 3 comma 3. We can see in the third day he is getting 3 coins. So this is true. J will increase by 4. So 3 comma 4. Can the geek achieve 4 coins while working in these 3 days? If he works for the first day and the third day, he will get 1 plus 3 equals to 4 total coins. Thus this condition is satisfying. We will update the value. Now 3 comma 5. If he works for the second day and the third day, he will get 5. So this will be true as well. Then again j will increase, and for 3 days he can get 6 maximum coins because the total of each element for 3 days is 6. So we will update the value of this index again, and the rest of the value will be false. The reason I have discussed it before. I will be increased and let us do that first. Now I will be increased again. So by now we are clear that if he codes for 4 consecutive days, he can get 1, he can get 2, he can get 3 and 4. So we will update the values till the 4th day. He will get 4 coins. What about the 5th day when I is 4 and our J is 5? So can the geek work for 4 days and collect 5 coins? Let us check. So if he works for the last day and the first day, he will get total 1 plus 4, that is 5 coins. So we will update the value like this. Then J will be increased, it will be 6. For working or coding for 4 days, can he achieve 6? So if he code for the last day and the second day, he will get 6. We will update the value likewise. And 4,7, this is also possible. 4 plus 3 is 7. So 4 plus 3 plus 1 is 8. So we will get true for this also. 4 plus 9, that is 4 plus 3, 7 plus 2, that is 9. So we will update the value by true. And the maximum the coder can gain in these 4 days is 4 plus 3, 7, and 2 plus 1 is 3, so 10. So he can get maximum at most 10 coins while coding for 4 consecutive days, and the rest of them will be false. Then coming to the last iteration when I will be 5 and J will be start over from 1 again. So while working or coding for 5 days, can he achieve 1? Yes, we have discussed it, and we can say that so like every iteration we will check whether he can get the required coin for that day or not. Now as we have done in our previous iteration also, we will keep on increasing our jth index and check whether that particular sum can be gained by the programmer in the given number of days. So in 5 days, can he collect 6 coins? Yes, we can collect. 5 plus 1 is 6. So accordingly, I will calculate and update all the indexes of the matrix. It is true. We can get this. We can get 9 also, 10 also, 11 is possible, 12 is also possible, 5 plus 4 9 plus 3 12 and 2 is 14, so 14 is also possible, and if we add all the elements we'll get 15, so this is also possible. So by now we are with our result in the last row of our matrix. Now just we have to check all the 3 given conditions in our problem and we are good to go. So without wasting any time, let's dive into the code and see how we will do this program. So at first we are taking a variable to calculate the sum of all the coins. Then we will iterate in our given array in coins and add up all the values in our given array. So by now we are with our total number of coins available. Now as we have discussed, we will create a matrix, dynamic matrix. So boolean dp is equals to new boolean. The size will be n plus 1 and the total sum we have calculated plus 1. This has already been discussed, and let us code it fast. Now we will work for our base case where when the sum is 0, we have seen it can be achieved in any number of days. In the first day without coding anything we can gain 0 number of coins. So similarly in the 5th day also we can get 0 number of coins. So by default in our base case we will add true in our first column of a matrix. So let's run a loop for that, and it will iterate till n times, that is the size of our row, length of our row, and it will increase by 1. We'll update our dp's ith index and the 0th column by the true value. So this is our base case. Now we will iterate through every indexes of our matrix and update its value. We will start from the first row and it will run till I equals to n, and I will be increased by 1, and for each time j will be starting from 1, and it will iterate till the sum, the total number of sum, and j will be increased by 1. All these logics are discussed in the first part of the video. Now we will check if the total sum is less than the number of coins he will gain if he codes for that day. So how we will get is we will search in our coins array. If this condition is true, that means the programmer has already the maximum number of coins with him. So no more coins need to be added, and thus the condition is invalid. So we will update its value by the previous row's value, which was false before. And the second condition we will check, that is if the sum is greater than equals to the coins which he may gain if he work for that day, that is I minus 1. If this is true, this is a valid condition, we will update our value of ith row and jth column by the value of previous column that was true in our case, because our base case was true. So the all the values of previous column was true, so we will decrease our row by 1. The maximum value of coins he will achieve, that is given in our coins array, we will OR it by the previous value of this index, that is dp of I minus 1 and j minus 1. So by this we have updated all the values in our matrix, and our last job was to iterate through the last row in our matrix. So we will start from the first index and run a loop till the calculated sum, which is total number of columns in our case, and we will increase I by 1. And here we will check all three conditions which we have discussed or which were given in the program, that is if I mod 20 is equals to 0, or I mod 24 is equals to 0, and the last condition was if I is equals to 2024 exactly, then we can return true if all these condition meets, and also if the value in our dp matrix is true for that index, that particular index. If this both condition satisfy, then we can return true, else we will get out of the loop. And if it is false for every cases and conditions, we will at last return false. So this is all about the program. I hope the logic is clear. We have discussed each and every part of the program. Now let's check whether we have any issues or not. So sum is declared with 0, sum is calculated. Okay, this was sum, not sums. Okay, so here we will add coins, coin, not coins. Now I think we are good to go. Let's compile. So compilation completed. Let's submit our code. So our code is running completely fine. Now if you think you have learned anything new from this video, please like, share and subscribe, and let's meet in the next video.